Hi everyone! Today's lesson is going to be about acids and bases. We've been talking about acids for a while. We've talked about sulfuric acid in the context of copper mining. We've talked about sulfuric acid in the context of ester synthesis. And you've seen carboxylic acid in our unit on functional groups, but you haven't really learned what an acid is. And that's what we're going to talk about today. So for a while, chemists classified substances as being either an acid or a base. And they didn't really have any kind of chemical understanding of what that meant. It was just categories that they created to lump together and name certain substances that had similar properties. So chemists decided that acids were a collection of substances that tasted sour and they reacted with metal. Bases, on the other hand, were a category of compounds that chemists saw that often tasted bitter and were very slippery. So classical examples of an acid would be lemon juice, very sour, and it can actually cause objects to rust and to react with metal. And a classic example of a base is soap, very slippery. So there are many different ways to explain what an acid is and what a base is at the chemical level. And today you're going to learn the very first definition of acid and base that came about, and those were created by a man named Arrhenius. He was a chemist in the late 1800s, early 1900s. So Arrhenius, you can see a photo of him over here, is famous for creating the first chemical definition of acid and base. That means he created some kind of model for what, in a molecular or atomic level, made a substance an acid. And here's what he said. According to Arrhenius, an acid is any substance that lets off a hydrogen ion when it's mixed with water. And a base, by comparison, he said, is any substance that lets off a hydroxide ion. So remember, hydroxide is one of the polyatomic ions you learned about a couple of lessons ago. So a base is any substance that lets off hydroxide ion, again, when it is mixed with water. So let me show you a couple examples. So if we look down here, we've got two chemical reactions. In the first one, we have HCl, and you should know that HCl is an ionic compound because hydrogen and chlorine can dissociate, that means come apart, to form ions, right? Hydrogen likes to have a +1 charge, chlorine likes to have a -1 charge. So this would be considered an acid because when you add it to water, the ions dissolve. Remember, we looked at and we talked about dissolution. That's when a solid ionic compound dissolves, right? And we get a hydrogen ion, right? So this is an acid. In the next compound, we have NaOH, which again is an ionic compound. You can hopefully predict by now that it will dissociate, that means dissolve, into sodium ion and hydroxide ion when mixed with water. So this compound would be considered a base because it lets off hydroxide ion. Now, this does get a little bit more complicated with acids because the hydrogen ion does actually react chemically with the water. What happens when you have hydrogen ions in water, they actually combine to form a polyatomic ion called hydronium. So you can see here the hydrogen ion reacts with water. And instead of just calling it hydrogen, we actually call it hydronium, right? And it's oxygen with 3 hydrogens instead of the usual 2 that you find in water. But because this hydrogen has a positive charge, the hydronium ion will also have a positive charge. So what does that look like? Well, I could rewrite, if I wanted to be more accurate and more specific, the reaction of HCl in water to look like this. Last time I wrote H positive plus Cl negative. This time I'm going to erase the H positive and call it H3O positive. Again, and that's because the hydrogen ion from the acid reacts with water to create this polyatomic ion called hydronium. Okay, so that's what hydronium looks like. So last but not least, I'm giving you a list of common acids and common bases, and these come up a lot in chemistry, and you just actually need to memorize their names. So here we have common acids, here we have common bases. So HCl, which I showed you before, is called hydrochloric acid. H2SO4, which you've seen in ester synthesis, is sulfuric acid. HNO3 is nitric acid. HClO4 is chloric acid. H3PO4 phosphoric acid, and CH3COOH is acetic acid. And I'm going to make one quick note about acetic acid, because it might be a little confusing that it's got 3 H's here and then a 4th H over here. Why don't we write them all together? Well, acetic acid is actually a carboxylic acid. So it's got C, H, H, H. Sorry. C, H, 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 those are the 3 H's. A second C, double bond O, O, H. So the reason it's written CH3COOH instead of just C2H4O2 is to actually show you that it is a carboxylic acid, and the hydrogen that's going to get lost in solution is this one. So when acetic acid dissolves in water, you get CH3COO negative and H positive, or H3O positive, which is hydronium. Okay? Last but not least, common bases: sodium hydroxide, very common, NaOH, potassium hydroxide, calcium hydroxide. This is actually not written correctly. Calcium is a 2 positive ion, so it should actually look like this. And last but not least, magnesium hydroxide.